and radical functions, and we're going to actually graph the square root functions and then graph square root inequalities. So that's our what we're going to try and do today. So a square root function is an equation that has a variable under the square root symbol. Okay, you have to have a variable under the symbol. You can't just have a number. Okay. It's basically the top half of the inverse of y equals x squared. A critical point that you want to find is the initial point, and to do that you set whatever is underneath the radical, you set that equal to 0. So in this case, this one is easy. It's x is equal to, you can put equal to or greater than or equal to, I like that greater than or equal to better, 0, and then plug 0 in. So f of 0 is equal to the square root of 0, so our initial point is 0, 0. That's this point right here, 0, 0. The domain is linked to the initial point. The smallest value is the x-coordinate of the initial point, and it's going to go off to infinity. That's when it's opening like down like this. I call this open down. The range is linked to the initial value. It is the smallest point to positive infinity. The x-intercept in this case is 0, 0, right here. So is the y-intercept. The end behavior is linked to, on one end, to the initial point. So as you talk about what's happening going left, as x goes to the initial point, 0, f of x in this case is going to 0. As x goes to positive infinity, in this case, so is f of x going to positive infinity. These end behaviors will change as the initial point changes and the direction of the opening changes. So let's just practice stating the domain, the range, and the initial point. To find the initial point, you set, whoops, I'm not sure why this is going crazy. You basically you set the radicand greater than or equal to 0. So x minus 3 is greater than or equal to 0. So x is greater than or equal to 3. The other way to do it is to take the opposite sign of this value. So I get positive 3. And then I take whatever is being added or subtracted outside or after the radical. So that would be 0. The other way to do it is to plug it in. So f of 3 is equal to the square root of 3 minus 3, and that equals 0. Okay. The domain is tied to my initial value. So it's 3 to positive infinity. The range is 0 to positive infinity. For number 2, again, there's nothing being added or subtracted under the radical sign, so you could look at it as a 0 x-coordinate, or you could say x has to be greater than or equal to 0, and then plug that in. F of x is going to equal square root of 0 minus 3, so that's negative 3. So we get initial point of 0, negative 3. The domain is going to be from 0 to positive infinity, and the range is going to be from negative 3 to positive infinity. Why don't you go ahead and try number 3 on your own. Come back and check your answer. That'll be your video question. So my initial point is going to be the opposite of 6, and then 2. The domain, I'm just tired of this thing doing what it does. I just can't stand it. Is going to be from negative 6 to positive infinity, and the range is going to be from 2 to positive infinity. The range might change if you have a negative out in front. I'll show you an example of that as we start graphing, which is what we're going to talk about now. We're going to talk about those transformations that we've used all year long. Reflection, you have a negative in the front of the whole system, so negative would be right here. Dilation, it'll be a stretch when A is bigger than 1. It'll be compressed when it's between 0 and 1. Horizontal shift, left if it's an x plus h under the radical sign, right if it's an x minus h, it's the opposite direction of h. And then the vertical shift is going to be up if it's positive k and down if it's negative k. So here's your k, here's your h, here's your A. All right, same spots that we've used before. So let's try and go through one. We're going to graph the following. My initial point is going to be the opposite sign of 4. So it's going to be negative 4. And then because I have a plus 0, there's nothing being added. It's going to be negative 4, 0. You could always set your radicand greater than or equal to 0 and then plug it in. My domain is going to be negative 4 to positive infinity. My range is going to be 0 to positive infinity. I'm going to make a table, and when I do that, I start with my initial point, and then I choose whatever makes these perfect squares on the inside. If I plug in a negative 3, I get the square root of 1, which is 1, times 2, which is 2, plus 0. If I plug in a 0, I get 4. The square root of 4 is 2. 2 times 2 is 4. And if I plug in a 5, I get 9. Square root of 9 is 3. 3 times 2 is 6. Not sure, not sure, not sure why my machine is doing this. So this was 6. All right, so let's get these on the graph. Negative 4, 0. Here we go. And negative 3, positive 2. Here we go. 0, 4. Here we go. And 5, 6. Here we go. And so my graph goes like so. Okay, it's that curve close to the initial point, and then it flattens out. My end behavior, so think about this. Think about as x goes to the left, it's going to that initial point, right? So as x goes to negative 4, f of x is going to 0. Those are both tied to the initial point. And then as x goes to positive infinity, f of x is going to positive infinity. The transformation, not reflected because there's no negative, so I'm stretched, and then I'm left 4 and up 0. Okay, left 4 and then up 0. Okay, we're going to try one that has a negative in front, so that means it's going to kind of flip it upside down. It's going to be reflected. My initial point is still the opposite of that of h, and then k, which is 1. My domain is going to be from negative 3 up to positive infinity. My range, I'm going to leave that blank for a second so that we can take a peek at what the graph is doing, because it's a little bit different when it's flipped upside down. I'm going to make my table. If I plug in a negative 3, that goes to 0, and then and so 0 plus 1 is 1. If I plug in a negative 2, that gives me 1. The square root of 1 is 1. And then the opposite of that is negative 1 plus 1 is 0. You can always plug this into your calculator. 1 plus 3 is 4. Square root of 4 is 2. Negative 2 plus 1 is negative 1. Square root of plugging in 6, square root of 9 is 3. The opposite of that is negative 3 plus 2 plus 1 is negative 2. So I'm going to graph these, negative 3, 1 right here. That's my initial point. Negative 2, 0 right there. 1, negative 1. 6. 1, 2, 3, 4, 5, 6. Down to negative 2. So this is not there. Let me erase that. That one's not there. I put that in the wrong spot. It should be here. And again, it gets going to go down and then flatten out. Goes down pretty flat and then flattens out. Goes down pretty fast and then flattens out. My end behavior, got to take it to the initial point. So as x goes to my initial point, -3, f of x is approaching negative or positive 1. As x goes to positive infinity. Now watch what's happening here. As x goes to positive infinity, where is my y's going? Well, they're going down. So f of x is going to negative infinity. So now let's go back and take our range. All right. My smallest value now is negative infinity, and my biggest value now is my end point, which is 1, my initial point. Describe the transformations it's reflected. It is left 3, and then up 1. That would be how we would describe the transformations. All right, now we're going to transition into inequalities. So we're going to find that initial point. We're going to plot some points, and then we're going to test. The thing that you have to remember is that your graph or your shading cannot go to the left of your initial point. So my initial point is going to be the opposite of -4, and then -6. 4, -6. I plug that in to my table, and now I'm going to pick values that give me perfect squares. 5 minus 4 is 1. Square root of 1 is 1. 1 minus 6 is -5. Then I chose 8. 8 minus 4 is 4. Square root of 4 is 2. 2 minus 6 is -4. And then I'm going to pick 13. 13 minus 4 is 9. Square root of 9 is 3. 3 minus 6 is -3. So as I plot these, I'm at 4. Okay, so I'm going to make a dashed line here. I'm going to choose red for it because I cannot go on my shading to the left of that line. Okay, and then I have 5, -5, so that's here. 8, 6, 7, 8, -4, 9, 10, 11, 12, 13. Okay, so watch. I'm going to go up steep. Sorry. I'm going to go up steep and then flatten out. Okay, now I have to shade. So I have to pick a test point. It has to be to the right of that red line. So I'm going to pick -8, 0. I'm going to pick this point right here. Okay. -8, 0. So when I plug in a 0 for y, is 0 less than -4? Is 0 less than -4? That's false. So I'm going to shade away from that point or on the other side of that line. So I'm going to shade down here, and I'm going to be careful not to shade to the left of my red line that I drew there. Okay? And then this line here should also, because this is an exclusive situation, I'm going to do this in red. This should be a dashed line, just like we did before. That's a dashed line. Here's our last example. We're going to graph the inequality f of x is greater than or equal to, so we'll have a solid line. And then the opposite of x plus 2 square root minus 4, my initial point. Opposite of 2 is going to be -2, and then -4. That's my initial point. And then I'm plugging in things that make me have a perfect square root under the radical sign. So -1 gives me -5. I'm going to skip 0. I'm going to plug in a 2. 2 plus 2 is 4. Square root of 4 is negative 2. Negative 2 minus 4 is negative 6. And I'm going to plug in a 7 because 7 plus 2 is 9. The square root of 9 is 3. Negative 3 minus 4 is negative 7. So now I'm going to plot these points. I have negative 2. Here's negative 2, and I'm down at 4. 1, 2, 3, 4. Okay, so here's, and then I'm going to switch my color because I'm going to draw a red line here because I can't go to the left of that red line. Otherwise, I get negative roots, and I can't have that in the realm that we're in here. And I have negative 1, negative 5, and then I have 2, negative 6, and then I have 7, 3, 4, 5, 6, 7, negative 7, and I'm going to connect them with a solid line because this is inclusive. So I'm going to go like this, and now I have to test a point. Well, look here, 0, 0 is to the right of that red line, so I can use it this time. So I'm going to use 0, 0, and then when I plug in 0, 0 is 0 greater than or equal to negative root 2 minus 4. Well, this is just more negative. Is 0 greater than a negative number? That's true. So I'm going to shade towards. And I'm going to use my highlighter. And I'm going to shade up in here. Okay. All right, this is our assignment that we're going to work on tomorrow. Thanks for listening, and I will see you tomorrow.